Hello and welcome to a new lesson. In this lesson, we would learn about counters in MapReduce programming. Counters can be categorized into two subcategories. First category is task counters, which would have counters pertaining to the tasks. And second category is the job counters, which have the counters associated to the whole job. Task counters are passed over to the task tracker and then they are sent over to the job tracker, which would aggregate the counters from all the map tasks that are running. When these task counters are passed, the complete image of task counters is sent and not just the change or the delta updates as we call them. It is done so in order to avoid the errors in case of loss of message in transmission. Task counters can be subdivided into user-defined and built-in counters. User-defined counters are generally designed to help the user understand the nature of the data that's being processed. Job counters, on the other hand, measure the job level statistics. They are maintained at Job Tracker in Classic MapReduce or Application Master in Yarn. It would have data like total number of reduced tasks and map tasks and so on. Let us look at the output of one of the MapReduce job and understand it in little depth. This is an output of a job run. It starts with the total number of input path, that is 1 in this case. Then it shows the progress of the job, how it is happening. Remember that the jobs can run for a long time and so this feedback mechanism is required so that user knows that the job hasn't hung. As we have already seen, 33% of reduce time is divided between shuffle, sort and actual reduce method. So at this point probably it just completed the shuffle step. Next comes the counters and its details. It says counters to be 29. That means that there would be 29 counters in all that would be displayed. Now as we have discussed, the counters can be divided into two portions. First, job counters, and secondly, the rest of them, which are the task counters. Job counters show the number of reduce and map tasks that ran, the time spent on running of reduce and map tasks. It also shows how many maps got the advantage of data locality. Slots mills reduce shows the time it took to run the reduce method in milliseconds. So it is 9350 here. And then comes the task counters. And these are all built-in counters which we can further divide into file output format, which contains the number of bytes written, then file system counters, which has the details of the bytes written and read from the file system. In this case, it is HDFS. It can be local file system as well in case of standalone mode. Here you see a high value as this is the net bytes written and read from a file system and it is not the number of bytes written to a file. So there is a little metadata that is being transferred. Then comes the file input format counters, which shows the number of bytes that were read by map task. Then comes the counters for the MapReduce framework. Map output materialized bytes show the number of bytes that are written to the disk by the map task. Then comes the input records which map has processed. Reduce shuffle bytes shows the number of bytes that were shuffled across the network. Spilled records show the number of records that were present on the spilled data. Map output bytes show the number of bytes output by the map. Total committed heap usage is the number of bytes that were used by the job. It is an important metric, particularly when you want to know how much main memory is being utilized by your job. CPU time spent gives indication of CPU usage. Combine input records shows the number of values that is iterated by the combine in its input. Remember, the keys won't give the real input records to the combiner, but the values would, as input to combiner is in the form of keys and list of values. Split raw bytes represents the split metadata rather than the split data itself. Reduce input record shows the number of input records to the reducer. Combine output records shows the number of output records by the combiner. Physical and virtual memory shows the amount of physical and virtual memory that is being used. Reduce and map output records show the number of output records that map and reduce functions output. So these are the various indicators which can give understanding about the input-output data and the processing mechanism. Next, let's learn about the user-defined counters. The general idea behind designing the user-defined counters is that they would bring out the meaningful insight about the data that is being processed. Furthermore, as a good programming practice, it is recommended to have counters which help the user to understand the data that is processed. So in general, the map side algorithm would look like map function and the processing logic. It is always recommended to save the processing logic with the if clause and check if the data record is in the proper format. If it is not, it should increment a counter, so at the end of execution, the user would be able to see what percentage of the records have fallen into bad category and if the result produced is actually depicting the large portion of data. Counters are employed through the context object in the recent versions of Hadoop. In the earlier versions of Hadoop, reporter object was used, although the programming structure is exactly the same as we look here.